These are some more questions from 2.4 in the AP Calculus textbook on chain rule. The derivative of e to a power is going to be e to the same power times the derivative of the power. So it's e to the same power times the derivative of the power. Well, what is the derivative of the square root of x? It's x to the 1/2, so you could do power base, 1 less power derivative base, which becomes 1 over 2 radical x. And now this is dy dx because I found its derivative. And so I'm going to put this on top times top and bottom times bottom. And that's your answer for number 71. So that was number 71, but I might move to one of the earlier questions here, like 31, or let's start with 31. 31 here is a quantity to a power. So I'm going to use the power rule, which does involve the chain rule. So it's the power times the base to the 1 less power. Now I need times the derivative of the base. The base is a quotient. How do I find the derivative of a quotient? Well, you use the quotient rule. So you have the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. So right now I have 3. I have 1 minus 2v, that is squared. On bottom I have 1 plus v, and that quantity is squared. And over here I'm multiplying it by something that has a 1 plus v squared also on the bottom. So I notice on bottom I'm probably going to have the 1 plus v quantity to the 4th, because squared times squared adding exponents. So let's clean up the numerator. This would give me negative 2 minus 2v, negative 2 minus 2v. I'll distribute the negative, so it'd be negative 1 plus 2v, negative 1 plus 2v. So it appears that on here you're going to have a 3, a 1 minus 2v, quantity squared. Now what does this part become? Well, what does it become? You get negative 3, I think, right? Is that correct? So it looks like it might be negative 9, 1 minus 2v, quantity squared, divided by 1 plus v, quantity to the 4th. Let me check the answer. Give me 1 second. Okay, let's see. After 31, I think I might have gone to 27. 27 is another quotient, so I'm going to do a quotient rule. So here's how I'm going to do it. The bottom times the derivative of the top minus the top times the derivative of the bottom. Since the bottom is to the 1/2 power, it'd be power base, 1 less power, derivative of base would be 2x, and then it would all be over the bottom squared. So what I did was I did a quotient rule. U over v. This is v u prime minus u v prime all over v squared. So I'm going to clean this up. I'm going to call this the square root of x squared plus 1. This 2 and this 1/2 will cancel. X times x is x squared. And I think that puts a radical on the bottom. And then the whole thing is over just x squared plus 1, because when you square the square root, it goes away. So basically, I just rewrote what I had before. Now, what is the opposite of dividing by the radical? Multiplying by the radical. I'll never accept a fraction and a fraction for an answer. When I multiply here, what do you get? I hope you get the radicand, the part under the radical. Minus, when you multiply here, would these cancel, leaving you just x squared? So, and on bottom you have x squared plus 1 to the 1 1/2. This is to the 1, and the square root is to the 1/2. X squared and negative x squared will add to 0. So the answer the book is going to have would be something like this. And I think the power would be 3/2 on the bottom. Yes, this could be written also as 1 over the power over root. It could be the quantity cubed. So this is also equivalent. Because it was written with radicals, it's probably better to answer in radicals. After 27, I'm going to try 47. The derivative of cosine is negative sine of the same angle times the derivative of the angle. So here's the answer for 47. 49. Can you keep the 5 out as a constant factor? What is the derivative of tangent? Well, it happens to be secant squared of the same angle times the derivative of the angle. 5 times the 3 making 15 secant squared of the same angle. Okay, after 49, I'm going to try 69. The derivative of e to a power is e to the same power times the derivative of the power. In other words, the derivative of e to the u is e to the u times u prime. So your answer is going to be 2e to the 2x. How about number 71? This is the same as e to the square root of x, which is x to the 1/2. So if I had to write my answer for the derivative, it'd be e to the same power times the derivative of the power. If you haven't done enough derivatives of square root of x to know it's 1 over 2 radical x, please realize when you do power base 1 less power, derivative of base, that's what you end up with. But how would I write my answer now? Top times top would be e to the radical x. Bottom times bottom is 2 radical x. Any questions on 69 or 71, Brian?
Yep.
Okay. If you do not know your logarithm rules, you're going to wish you did. Because you can do it the hard way or you can do it the easier way. I'm not sure we're there yet, but let's see if we're on logs. Yes, here we're on some logs. One of the properties is log of a to the b power is b times the log of a. In other words, you can pull your exponent out front. So this is going to come out front. And it's going to be x squared times the natural log of e. Well, e to what power is e? 1. This is just a disguised form of x squared. And what is the derivative of x squared? Hopefully everybody knows that it's 2x. A lot of people think up here natural log and e eliminates each other and all it's leaving you is x squared. But here it's done proper with the properties. Okay, after 75, we're going to look at 77. How could 77 be rewritten? Could it be this raised to the -1? Okay, so we have rewritten number 1. Now I'm going to find its derivative. I only rewrite these when there's a constant top or a constant on bottom. So this is a constant on top. Keep the constant factor out front. Power, base, 1 less power times the derivative of the base. Well, the derivative of e to the x is e to the same power derivative power. E to the same power times the derivative of the power. So I have a negative 2. I believe this would be e to the x plus e to the negative x, and that's going to go to the bottom and become squared because of the negative 2. And this is going to be e to the x minus e to the negative x, because that's what it becomes. So you end up with negative 2 e to the x minus e to the negative x, all divided by e to the x plus e to the negative x quantity squared. Okay, let's just take a look at it. I rewrote it, but I think this should be the derivative. Okay, following 77, I wanted to look at 89. Is there a property that says log of A times B could be broken up into log of A plus the log of B? So I'm going to break this thing up into the log of X plus the log of the square root of x squared minus 1. Okay, I use my properties to rewrite them. There is another property of logarithms that is the log of a to the b power is b times the log of a, which allows me to pull the exponent out front. So that's what I'm going to do with this 1/2. So still, before I differentiate, all I'm doing is rewriting it to make my job of differentiating it a little bit easier. Okay, I still have not taken the derivative. All I've done is rewrite it. Now I'm going to take the derivative. Now, do you agree that the derivative of natural log of u, the derivative of natural log of u is 1 over u times u prime? Could also be written as u prime over u. So, u prime over u prime over u. So that gives me this plus the 2's canceling this. And it works out pretty nice with the common denominator. To get a common denominator, you just multiply your two denominators, x times x squared minus 1. This first one is missing a x squared minus 1, right? So what would that give me on top? X squared minus 1. Whereas this other one is missing what? It's missing an x. And what does that make? X times x on top, x squared. So what's going to be my final answer should be 2x squared minus 1 over x times quantity x squared minus 1. Okay, we're going to move to one more here, number 71. Looks like we've already done it. Anyway, I hope these help. Good luck.